Hi all, welcome to new video of AK Math Academy. Today we are going to see some questions from exercise 5.1 of class 12 continuity and differentiability. So let's begin. Question C is similar, very much similar to question B itself. I mean the subpart B itself. What it says, f of x is a function which is given x square minus 25 by x plus 5, and we should find whether it is continuous at all points except x equal to minus 5. Okay, just observe. What happens if we apply a limit operator in this function at point x equal to minus 5? Just substitute minus 5 here. What will we get? Denominator will become 0, hence the function will become not defined or infinite. Hence we can say that function is continuous at every point except x equal to minus 5. The very similar question as what we saw in question B. So we can say that f of x continuous at all points except x equal to minus 5. This is how we solve this question. Okay, this is a modulus function. So this we will solve by using left hand limit and right hand limit. Okay, so let's write left hand limit. Left hand limit will write as limit x tends to c minus f of x, which is equal to limit x tends to c minus of mod x minus 5, which we'll get as mod c minus 5 itself, which is c minus 5. We'll get the absolute value, right? So c minus 5. Okay. Now right hand limit, which is limit x tends to c plus f of x equal to limit x tends to c plus of mod x minus 5, which will get c minus 5 itself, c minus 5. Here they didn't give any conditions, whether like for example the functions become 0 if x less than 0, the functions become 1 if x greater than 0. They didn't give any condition, so we'll just write absolute values here, or else if they gave conditions then we'll do accordingly some modifications. So here we'll just prove that LHL equal to RHL, hence it's a continuous function at all points in their domain. Okay, now let's understand this with the help of a graph. Okay, let's understand this question with the help of a graph. It's very easy. So let's imagine y equal to f of x. So we can write the equation as y equal to mod x minus 5. So let's give values for y and x. So x and y, I am plotting a graph. So I am giving the values. This gives only positive values, right? Mod operator only gives positive values outside. So what happens if I put x as 1? Inside we will get 1 minus 5, which is minus 4. But when it comes out of mod operator, it becomes plus 4. Note it, it becomes plus 4. It only gives positive values outside. Okay. So x1 means y becomes 4. Okay. Let's take x value as 3. So what happens if we take value of x as 3? Inside it becomes 3 minus 5, which becomes minus 2. Since it's negative, it gives outside as plus 2. Now let's take value as 5, we'll get 0. Let's take value as 7, what will get? 2, right? Let's take value as what will take value? Okay, 9, what will get? 4. Okay, now let's draw this graph. So graph will only be there in second quadrant because x and y values are positive for absolute functions or modulus functions. So first one, x1 and y is 4. y is 4, so somewhere here, right? So x1 and x1 and y4, and y2 and x3. y2 and x3, it comes somewhere here, and y0 and x5. y0 and x5 comes here, right? And y2 and x7. y2 x7 comes here, and y4 and x9. y4 and x9 comes here somewhere. So if you notice the graph, it comes something like this. It gives something like this. Sorry, y4 and x9 passes through that point. So see, it gives something like this. There is no breakpoint in this graph. It gives continuous straight line, because see, there is no any breakpoint. So we can say that modulus functions are continuous. This particular modulus functions is continuous. Okay, it's very simple, right? We'll be solving the next question in the next lecture.